Hello everyone, today we'll be covering the topic of transformations. I think transformations is one of the most important topics when it comes to graph drawing. Understanding how transformations work really helped me understand how to draw graphs properly. For IB, there are three types of transformations that we'll be learning: the translation, stretching, and the reflection. These transformations are all somewhat related to the x and y axis. When you describe the transformations, please try to follow the phrasing that I have over here. For example, for translation, which is a movement, please do not use the word move or shift. Use the specific mathematical term translation. First off, let's start with translation. Translation is a movement of the graph in either the x or y direction. So let's start off first with the translations in the y direction. Please refer to these two over here. So let's say we have the graph of fx over here on the right. If we want a translation of a units in the positive y direction, this means that we have to do fx plus a. So what we're doing here is that we're shifting all the points upwards by a factor of a. So a point over here, let's say 0, 4, will actually become 0, 4 plus a. And similarly, if we want a translation of a units in the negative y direction, that means going down, this means that we need to have fx minus a. So let's move this down. By a units, this is fx minus a. Do remember that the a is outside the bracket for a translation in the y direction. For the x-axis, however, we change the x inside the bracket. So let's say we have fx minus a. Please refer to these two over here. Fx minus a will be a translation of a units in the positive x direction. So if I draw the graph over here, this is a translation of a in the positive x direction, fx minus a. My teacher liked to tell me that x is a rebel, and especially for this reason. A leftward shift, or a translation of a units in the negative x direction, will be fx plus a. So what this is a translation in the negative x direction by a units. One more thing about translation, if they give you a translation by a vector alpha, beta, as you can see over here, this means that fx becomes fx minus alpha plus beta, meaning a translation of alpha units in the positive x direction, and then a translation of beta units in the positive y direction. That's what fx minus alpha plus beta means. Now let's move on to stretching. Let's first start off with the stretching in the y direction. So focus on this one over here. If you want to stretch on the y-axis by a factor of k, we'll take k times fx, where the k is outside the bracket. So let's say we want 2f of x. That is a stretching on the y-axis by a factor of 2. So if we draw that, this is what 2f of x looks like. This means that all the points kind of get stretched upwards to double its height. So you have this point over here, it goes up to this point. This point over here goes up to this point. So maybe this point is 1, 2. This point up here will be 1, 4. Similarly, maybe this point may be 2, 3. This point up here will be 2, 6. Again, doubling its height because we're stretching on the y-axis by a factor of 2. Now for the x direction, let's say we want f2x. Okay, f2x, like this. So f2x, if we look here, it means a stretching on the x-axis by a factor of 1 over k, or in our case, half. Remember, for any fkx, this means that it's a stretching on the x-axis by a factor of 1 over k, not k. That's why I say that x is a rebel. So let's look at the graph over here. What will f2x do? It's a stretching by a factor of half. So all the points get halved on the x-axis. Maybe we have a point over here, 2, 1. This point over here becomes 1, 1. This 2 over here gets halved because we're stretching on the x direction by a factor of half. Again, maybe this point is negative 2, 1. This point over here will be negative 1, 1. And finally, we have reflection. Let's focus on the first one over here. if we want to reflect on the x-axis, this means reflecting like this. We're reflecting all the points on the x-axis. This is the graph of negative fx. And for f negative x, this is a reflection on the y-axis. Let's say that our y-axis is here. What a reflection on the y-axis will just be reflecting all the points on the y-axis. So these points over here get reflected to those points. These points all over here will be reflected to here. Let's do a question. We are trying to transform the graph of fx in 4 transformations to the graph of gx, which is 1 minus 2x cubed minus 2. So usually what I like to start off with is the translation on specifically the x-axis, followed by the stretching. We'll see why a bit later. To go from x cubed to 1 plus x cubed, what we want to do is a translation of 1 unit in the negative x direction. If we look up here, remember that x is a rebel. If we want x plus 1, we want a translation of 1 unit in the negative x direction. So our first transformation is a translation of 1 unit in the negative x direction. Remember, whenever I want to do any transformation for inside the bracket, I would just want to replace only the x. So the next transformation I want to do is to replace x with 2x. So what does this become? 1 plus x cubed actually just becomes 1 plus 2x cubed. We're replacing x with 2x to get us closer to this. We are stretching on the x-axis by a factor of half. Remember, x is a rebel. It's not a factor of 2, but a factor of half. Again, remember when we are doing transformations for inside the bracket, we want to replace only the x. So to get from 1 plus 2x cubed to 1 minus 2x cubed, we want to replace x with negative x. So when we replace x with negative x, this is doing the reflection on the y-axis. Let me just move down here because I ran out of space. The last thing that I have to do to get from 1 minus 2x cubed to 1 minus 2x cubed minus 2 is the minus 2. So what this is, if you remember, is just a translation of 2 units in the negative y direction. So earlier, remember I said that I like to start off the transformation with translation on specifically the x-axis. Why do I want to do this? This is because the order of transformation really matters. I can't just jumble this up and say that I can stretch on the x-axis by a factor of half, followed by a translation of 1 unit in the negative x direction. That doesn't work like that. Let's actually take a look at what happens if we start off with a stretching on the x-axis by a factor of half. So remember, when we're doing a transformation inside the bracket, in this case stretching on the x-axis is a transformation inside the bracket, I want to replace only the x. So in this case, I'm replacing the x with a 2x. Now what I want you to see is what happens when we go from 2x cubed and we want to go to 1 plus 2x cubed. How do we do this? We need to do a translation of something, but is it a translation of 1 unit? No, it's actually a translation of half a unit. Why is this so? Again, when you're doing transformations inside the bracket, you want to replace only the x. If you find it a bit difficult to understand what I mean by replacing only the x, you can put a bracket around the x and just replace that. Okay, so let's actually try this. If you want to get 2x plus 1 cubed or 1 plus 2x cubed, the same thing, first you want to put a bracket around the x and we're just replacing what is inside the bracket. So remember, if we want to do a translation of some unit in the negative x direction, I'll do x plus something. And in this case, we can't do a translation of 1 unit in the negative x direction. We'll actually be doing a translation of half a unit. If we expand this, we get to 2x plus 1 cubed, which is what we need to get earlier on. My point in all this is that the order of transformation really matters. So you have to make sure that if you're stretching first, you need to be very careful with doing this. That's why usually what I like to do is start off with the translation in the x direction. Here's a summary sheet for transformations. Thank you so much for watching. I hope this is it. So this is the summary sheet for transformations. Thank you so much for watching. I hope you guys benefited from this.